Hi all, in this particular video we will see the classification of data structures. Basically means how many types the data structures are divided into some other categories or divided into some categories. That's the meaning of classification of data structures. The data structures are classified or divided based on three characteristics. That means the type of data it is stored and how data elements are interlinked with each other and how data is accessed. Based on these three characteristics, the data structures are divided into some categories. Now we will see what are those categories. This image is taken from logicmojo.com. The data structures are divided into two primary types called primitive data structures and another one is non-primitive data structures. When it comes to primitive data structures are the basic building blocks, and these are very essential to build non-primitive data structures. Primitive data structures are part of your programming language. When it comes to C, we have the primitive data types called int, float, char, double. And when it comes to Java, by the way, whatever you are seeing, these are the data types of Java: byte, short, int, float, char, boolean, long, double. These are the data types of Java. Okay. So primitive data types are generally contain only single value, and these are very easy to understand, and the memory representation also very simple. So that is the meaning of primitive data structures. So let us see the further slides. As I said earlier, primitive data structures are basic, and these are built-in data types. Built-in means these are part of your programming language. It doesn't matter when you take C programming language, there will be some built-in data types. When you take Java, there will be some primitive data types. When you take some other language, there will be some other built-in data types. So usually primitive data structures will store only one value at a time. What are the key characteristics? Primitive data structures store one value at a time. It is a fixed size, simple memory representation. So these are the building blocks of all your other data structures. And what are the non-primitive data structures? It will store multiple values. To put it simply, non-primitive data structures will store multiple values. It will maintain relationships between data. These are built using primitive data types. So it is derived data types. So you can say these are derived data types as well. What are some key characteristics? It can store large and complex data, and it can be static or dynamic. What do you mean by static or dynamic? Because arrays are static and linked lists are dynamic. Static here means you cannot increase the memory size, you cannot decrease the memory size. Once declared, that is fixed. This fixed memory allocation is called static memory allocation. When it comes to dynamic, you can increase memory slots or you can decrease the memory slots based on your programming requirement. So linked list follows dynamic memory allocation. We can non-primitive data structures used to represent real world entities. We will see what real world entities in upcoming video lectures. This is not the right time to discuss those things. And to give you simple information about non-primitive data structures, arrays can be used to do image processing. So for example, if you want to store images, you can use a concept called matrices. So matrices are part of 2D arrays, right? So that is the one real world entity. And trees, your network file systems are based on your trees. So these are some real world entities I can think of as of now. So there are so many other real world applications we can discuss in a while. So when it comes to linear data structures definition, a linear data structure in linear data structure, data elements are stored sequentially, or data elements are arranged sequentially. Each element has one predecessor and one successor, so except for first and last. When it comes to characteristics, we have single level structure, and it has a sequential arrangement of elements. And if you want to traverse, you can traverse it in one direction. Traversing means visiting each and every element of that particular data type. It is easy to understand and implement. When compared to non-linear data structures, linear data structures are easy to understand and implement. What are non-linear data structures? Non-linear data structures, in non-linear data structure, data elements are not arranged sequentially. In other words, here the data is arranged in hierarchical way or a network way. We will see non-linear data structures in last unit called Unit 5, where we will discuss a concept called trees and hash tables, where we will dive deep what are hierarchical data arrangement and all those things. In nonlinear data structures, one element can be connected to multiple elements. That is the meaning of nonlinear data structures. What are the characteristics? It follows multi-level structure, and it will have the complex relationships. And when it comes to traversing, we have so many traversal paths, because the one element connected with multiple elements, we can traverse it in multiple directions. Nonlinear data structures are efficient for large and hierarchical data. Some examples includes trees and graphs, where trees can be used, as I said in our previous video. Trees, we have the file systems, right? File systems like D drive, and inside D drive we will have one folder, and in one folder we will have separate folders, and in subfolders we will have some files. This file organization is entirely done in a data structure called trees. Okay, when it comes to graphs, there is something called maps. These entire maps are built using a data structure called graphs. When you want to go to one place to another place, you can use a data structure called graphs. And today's navigation systems like GPS, and maybe you can name some apps like Uber, Swiggy or Zomato, all uses the graphs, right? I mean, all uses the maps, right? These maps are internally built using a concept or using a data structure called graphs. Okay, and when it comes to the differences part, when it comes to the aspect, we will see some differences as part of one particular aspect. One such aspect is called arrangement. In linear data structures, the elements are arranged in sequential manner. When it comes to non-linear, the arrangement is not sequential, but the elements are arranged in hierarchical or network. Hierarchical is the tree and network is graphs. Basically, you can think like that. When it comes to levels, we have single level in linear data structures, and when it comes to non-linear data structure, we have multiple levels. Why is that so? Because one element can be connected to multiple elements. That is the meaning we will have the multiple levels. When it comes to relationship, we have one-to-one relationship in linear data structures, but in non-linear data structures, we have multiple relationship like one-to-one, one-to-many or many-to-many. When it comes to traversal, it's a single path traversal in linear data structures, but when it comes to non-linear data structures, we can traverse it in multiple paths. Because one element is connected with multiple elements, you can travel in multiple ways. Example, graphs. Complexity, when it comes to the implementation, linear data structures are very simple to implement. So the complexity is very simple. I mean, you can say there is no complexity at all when compared to non-linear data structures. And it is, when it comes to non-linear data structures, it is complex to implement. What are the some examples of linear data structures? It is array, stack, queue, and linked list as well. What are some examples of non-linear data structures? Trees, graphs, heaps, etc. And let us see some importance of linear data structures. So it is easier to understand, as I said earlier. It is efficient for small and medium data, but if you want to go to the complex and large data, you should go to non-linear data structures like trees and graphs. Widely used, even though the linear data structures are also used in real world applications, even though it is efficient for small and medium data, but arrays is very useful in image processing. Your stacks is a one data structure. The stacks are heavily used in undo and redo operations in text editors. And expression evaluation, whatever your 2 plus 3 into 5, these expressions are evaluated using a data structure called stacks. And balanced parenthesis, like we have parenthesis in parenthesis 2 plus 3. This balancing of parenthesis is checked using a data structure called stacks. And whenever you call a function in programming, these function calls are managed in one particular data structure called stacks. And the queues are very much useful in task scheduling in operating systems. Linked list is used in music players and web page navigation. And linear data structures are foundation for advanced data structure. That is the reason you should know the concepts of linear data structures. That's it for this video. I will see you in my next video. Thank you.